Hi students, in this video I'll be talking about two things. Okay, so the first thing I will be talking about would be the discriminant of a quadratic equation. And then the second thing I would like to talk about would be how is it related to the nature of roots, okay, of a quadratic equation. Right, so let's start off by talking about this thing called the discriminant. Okay, so discriminant. Okay, so where does the discriminant of a quadratic equation come from? Okay, so if you recall, a quadratic equation looks something like this: ax squared plus bx plus c equals to 0, right? Okay, so one way to solve a quadratic equation is to use the quadratic formula. Okay, so if you recall again, the quadratic formula goes like this: minus b plus minus square root b squared minus 4ac over 2a, right? Okay, so this thing inside here, this b squared minus 4ac is known as the discriminant. Okay, why is it known as the discriminant? You will know, it will be obvious to you later on after we have finished the discussion. Okay, so for now, you just keep in mind that this b squared minus 4ac is known as the discriminant. Okay, so this discriminant can basically in general take on three different types of numbers. Okay, so it's either it can be positive, a positive number. Okay, so a positive number, or it can be 0, or it can be a negative number. Okay, so it can take on this, in general, take on these three forms. All right. Okay, so let's first discuss what if the discriminant b squared minus 4ac, right? What if it's positive? Okay, positive means in other words greater than 0. Okay, so let's take a look at the first case. So if b squared minus 4ac is positive or greater than 0. So example, okay, b squared minus 4ac is a number like positive 4. Okay, then how many answers will we be able to get for x? Okay, then x will be, okay, so minus b in an actual question will have a certain number lah. Okay, a, b, and c in the actual question will have some numbers. Okay, but for now we are not concerned about what number it is, so I'll just leave it as minus b. Okay, so if b squared minus 4ac is 4, okay, so same thing for a. In actual question, it will be a number, but for now, it doesn't really matter. Okay, so I'll just leave it as 2a. Okay, so if we go on and solve this, plus square root 4 will give you 2, right? So it becomes plus minus 2 over 2a. Okay, in this case, you will see that you will be able to get two answers. One is minus b plus 2 over 2a, or minus b minus 2 over 2a. Okay, so these two answers are different from each other. One is minus b plus 2 on top, one is minus b minus 2 on top. So obviously, we are going to get two different answers. Okay, so since we get two different answers, okay, we call this real and distinct roots. Okay, that means the quadratic equation, this ax squared plus bx plus c equals 0, right, has real and distinct roots. Okay, real and distinct roots. Okay, distinct means different, right? Correct? Okay, and why is it different? Because we got two different answers. Okay, that's why it's different. Okay, so let's look at now the second case. So over here, just keep in mind you have two answers. Okay, two different answers. And okay, so second case. Okay, b squared minus 4ac is 0. Okay, if it's 0, okay, then x will be minus b plus minus square root 0 over 2a, right? Okay, so the square root of 0 is 0, so you'll get minus b plus minus 0 over 2a. Okay, so your two answers will be minus b plus 0 over 2a, or minus b minus 0 over 2a. But if you think about this, if you take minus b, you plus 0 or you minus 0, it doesn't make a difference, right? Okay, in the end of the day, you will still get the same answer, minus b over 2a, or minus b over 2a. So can you see these two answers are equivalent or equal to one another? So this one is what we call real and equal roots. Okay, real and equal roots. Okay, that means two answers, but the two answers are the same value. That means in other words, just one value only lah. Okay, one value or one answer. Okay, or one distinct answer. Right? So can you see the difference now? All right. when the b square minus 4ac changes from a positive value to 0. Okay, so let's explore the last case. What if b square minus 4ac is negative? Okay, what if it's negative? Okay, so if b square minus 4ac is negative, so for example, it's negative 4. Okay, b square minus 4ac is equals to negative 4. Okay, then x will be minus b plus minus square root minus 4 over 2a. So if you take your calculator and try to square root negative 4 now, you realize that there are no real solutions. Okay, so your calculator won't be able to give you a real answer. Okay, so in other words, you will not be able to get any answer for x. Okay, because square root negative 4 is no real solution, doesn't give us any real solution. So this one is what we call no real roots. Okay, so over here, this last case will be no answer. Okay, so you won't be able to get any answer. Okay, so going back to the question, why is this called a discriminant? Okay, so the discriminant means to differentiate, right? Between one thing to another. Okay, so you can see here when the b square minus 4ac change from positive to 0 to negative, we get three different scenarios that pan out. The first one is two answers, real and distinct roots. The second one is just one distinct answer, or rather one answer. Okay, both answers are the same, so real and equal roots. And then the third one, where b square minus 4ac is negative, then you have no real roots. That's why it's called the discriminant, because its value will determine how many roots, okay, or what type of roots the quadratic equation has. Okay, that's why it's called the discriminant. All right. Okay, so the next thing that I want to talk about will be to move on to something more visual. Okay, to move on to something more visual. Okay, so over here we have the first scenario. We have a curve. Okay, so the equation of the curve is shown over here. Okay, so it's 2x squared minus 3x plus 4. Okay, and the equation of the line, the blue line, is 2x minus 1. So over here you can see that the line and the curve do not touch one another. Okay, so they do not touch one another. Okay, so this means that if let's say I were to equate them together and try to solve, right, should I be able to get any answer? Okay, if I were to equate 1 and 2, so 1 equals to 2, right? Equate them together. That means I will get 2x squared minus 3x plus 4 equals to 2x minus 1. Okay, so we know that when we want to solve a quadratic equation, we will bring everything to the left side. Okay, so we will get something like this. Okay, so now my question is, if we try to solve this, whether using quadratic formula, using our calculator or what, right, function, okay, should we be able to expect any answer now? Okay, we should not be able to expect any answer, right? So in other words, this quadratic equation should have no real roots. Okay, no real roots. Okay, because the line and the curve don't intersect each other. So when you try to solve them simultaneously, you should not be able to get any answer. Okay, so let's try to verify whether what we've learned just now is correct or not. So let's calculate the discriminant of this quadratic equation. Okay, remember, a discriminant can tell us whether real roots, real and distinct root, real and equal, or no real roots. Okay, so let's calculate out the discriminant. Okay, so if you calculate this out, you get 25 minus 40, so you get negative 15. So indeed, it's less than 0. So can you see or not? When the line and curve don't intersect, when you try to solve them, you will not get any real roots. The quadratic equation should have no real roots, so the b squared minus 4ac should be less than 0. Okay, so this is a case whereby there is no real roots. Okay, no real roots. Okay, now let's look at the second scenario. Okay, so now we again have a curve. Okay, different equation, and a line, a different equation. Right? So over here you can see that the line and curve touch each other at just one point. Okay, so if I try to solve them simultaneously, okay, how many answers should I expect to get? If I try to solve them, solve this equation. So I'm going to bring everything to the left side. Okay, so I will get this, right? Alright. So if I try to solve them, I should only be able to get one answer. Okay, one answer means the second case from just now, right? Real and equal roots. Okay, so real and equal roots. Okay, so let's find the b square minus 4ac and let's use it to confirm. Okay, so let's find b square minus 4ac. Okay, so b is minus 6 square minus 4, a is 1, okay, c is 9. So 36 minus 36. So yeah, indeed, 0. Okay, so this quadratic equation indeed has real and equal roots. Okay, so can you see whatever we have discussed just now, we can, when we use it into a real question, okay, whereby we can visualize it. Indeed, it coincides, right? Okay, it applies. Okay, the concept is consistent, right? Okay, so let's look at the final case before we do an O-level question. Okay, so same thing, this is 1, this is 2. So over here you can see the line intersects the curve at 2 points, right? Okay, so intersects the curve at 2 points, 1 here, 1 here. So when you try to solve, you should be able to get 2x value and 2y values. Okay, so let's equate 1 and 2. And then we find the b squared minus 4ac. So now it's the real and distinct roots. So x squared minus 5x plus 3 equals to 2x minus 5 plus 8 equals to 0. Okay, so we should be expecting real and distinct roots, right? Okay. So in other words, when we calculate b squared minus 4ac, we should expect it to be positive. Okay. So get 49 minus 32. Okay, so indeed you get 17, which is greater than 0. Okay, so b squared minus 4ac is greater than 0. Okay, so the above quadratic equation, this one has real and distinct roots. Right? Okay, so the concept that we learned earlier on, the discussion, it applies, right? Okay, it's consistent. Okay, so let's end off this recap by looking at the O-level question. Okay, so I think this is from the 2018 paper, right? Okay, so the question goes like this. Okay, the equation of a curve is y equals to 2x squared plus k plus 2x plus k. Okay, in the case where k equals to 5, okay, show that the line y equals to 19x minus 13 is tangent to the curve, and then after that find the point of the coordinates of the point whereby the curve will touch the line. Okay, so when k equals to 5, so this for this particular part they say that when k equals to 5, so let's replace k with 5 first. Right, so if we replace k with 5, then the equation of the curve becomes y equals to 2x squared plus 7x plus 5. Okay, so let's call this equation 1. Okay, then the equation of the line, we will call it equation 2. Okay, so they say that show that the line is tangent to the curve. Okay, in other words, if we were to equate the line and curve and then we try to solve it, okay, so if we were to equate 1 and 2, okay, like what we did just now. Okay, so 2x squared and x plus 5 equals to 19x minus 13. Okay, 2x squared, you bring over 19 minus 12x plus 18 equals 0. Okay, let's simplify this one first. So in other words, when we try to solve this, okay, how many answers should we be expecting? So tangent, okay, this one is a smiley face curve because a is positive, right? Okay, so it's a smiley face. Tangent means it touch this way, okay, just like that. Okay, so it touch at one point. Okay, never draw for B. Okay, so the line and the curve, the line just touches the curve at one point. So we should be expecting one answer. Okay. Okay, so we should be expecting one answer. So how to verify that? Yeah, we find the b squared minus 4ac, and the b squared minus 4ac should become 0. Okay, so that's what we're going to find. So b squared minus 4ac equals to, okay, find the discriminant. So indeed you get 36 minus 36, so you get 0. Okay, so you can conclude that since b squared minus 4ac Okay, so let's use the word discriminant now, okay? For the above equation, okay? Is 0. The equation has real and equal roots. So y equals to 19x minus 13 is tangent to y equals to 2x squared plus 7x plus 5. Right? Okay, so since you only touch b squared minus 4ac is 0, so it means that it only touches at one point, hence the line must be tangent to the curve. Okay, then they also want us to find the coordinates of the point of contact, right? Okay, so all we need to do is solve this equation now, okay? Then we will be able to find the x coordinate. Okay, so this one can be factorized, so we get this. Okay, so this means that x will be equals to 3. Okay, then you just sub x equal to 3 into maybe equation 2. Okay, so 19 times 3 minus 13. Okay, so you will get 44. Okay. Okay, so therefore point of contact equals to 344. Right? Okay, so there's a second part to this question. Okay, so let's try it now. Okay, explain why. Okay, so this is a 4-mark question. Okay, this is actually a 4-mark question. Okay. Okay, explain why there is only one value of k for which y cannot be negative and state this value. Okay, so now k is no longer equal to 5, revert back to the original value. Okay, so the equation of the curve was originally this 2x squared plus k plus 2x plus k. Okay, so this was the equation of the quadratic curve. Okay, so let's read again. Explain why there's only one value of k for which y cannot be negative. Okay, so this is y. Okay, y is the equation of the quadratic curve, right? So explain why it cannot be negative. Okay, so let's draw and see. Let's draw and see what does it mean for a quadratic curve to not be negative. Okay, so basically there are two scenarios over here. The first one is the quadratic curve could look something like this. It lies totally above the x-axis. If you lie totally above the x-axis, then you cannot be negative. All right. So this is, remember, this is y equal to 2x squared plus k plus 2x plus k. Okay, so just now in the previous examples where I show you, there's always a line and a curve. Okay, but for this particular question, which line are we going to talk about? When you are talking about being cannot be negative or always positive. Okay, the line that we will now be concerned about will be the x-axis. Okay, because if let's say this curve is always positive, that means always above the x-axis. So when you try to equate the equation of the curve to the equation of the x-axis, right? Okay, okay, so in this case, this will be equation 1, this will be equation 2. Okay, so when you try to equate 1 and 2 together, okay, so you will get 2x squared plus k plus 2x plus k equals to 0, right? When you try to solve this one, the discriminant should be, okay, since the line, the curve doesn't cut the x-axis, then the discriminant should be less than 0. Okay, so from here, we should get b squared minus 4ac less than 0 for the above quadratic equation. Okay, so this is one possible scenario. Okay, let's talk about another possible scenario where it cannot be negative. Remember, they say it cannot be negative only, but cannot be negative can be 0 or not. Cannot be negative can be 0, right? So another possible case would be this curve just go and touch the x-axis. Okay, just touch the x-axis at one point. Okay, so in other words, if you do equation 1 equals to equation 2, okay, so same thing, this is the same curve, okay. Okay, so if you do equation 1, then you get this. Okay, so since this last case, okay, the curve touch at one point, right? Then the b square minus 4ac should be equals to 0. Okay, because you should be able to get one answer. Okay, but since this question state that y just cannot be negative, right? So what we need to do is we need to combine these two scenarios together. Okay, because these two scenarios both fulfill the what they want, cannot be negative. This one is always positive. This one is one point touching, okay, the x-axis, right? Okay, so we're gonna combine these two cases together. So how do we combine? So this one is less than 0. This one is equal to 0. So we'll just write less than or equals to 0. Okay. So let's extract out the b. So the b will be the coefficient of x, right? So it will be k plus 2 square minus 4. A is 2. C will be k. Okay. So A is 2, then C will be k. Okay, so let's expand this. You will get k squared plus 4k plus 4 minus 8k less than or equal to 0. Okay, so k squared minus 4k plus 4 less than or equal to 0. Okay, this one we can factorize it to this case. Okay, so how do we solve this? Okay, so they ask you to explain why there's only one value of k. So when we solve this, we should get only one value of k. Usually when we solve a quadratic inequality, right? Usually what we expect is a range of values. But in this case, we need to show that there's only going to be one value. So how are we going to show? Okay, if you look at this scenario that we have now, it looks a bit weird. K minus 2 squared less than or equal to 0. Okay, let's split this up and analyze it. Okay, I can split this up into two cases. Less than 0, since it's less than or equal to 0, right? Or k minus 2 squared equal to 0. Okay, I ask you one question. Is this one possible or not? Is this possible? Is there any value of k you can sub in? Okay, you minus 2, you square it, it becomes negative. It cannot, right? Not possible, right? Because we know that when you square something, it's either 0 or it's going to be positive. So over here, there's no solution. Okay, there's no value of k that can fulfill this condition. So there's no solution here. So the only solution can come from here. Okay, and this one is so easy to solve. The only value of k where you can sub in such that k minus 2 squared is 0 will be k equals to 2. Right? So only k equals to 2. So you have explained already. Okay, so that's how you explain. Okay, there's only one value. Okay. Okay, so the only value, so just conclude. So the only value for y to be not negative for okay. Okay, so I hope you understand this question. So actually, typically, questions from this particular chapter is a bit difficult. Okay, it's not that easy, right? So because it requires you to understand the concepts very well, right? So I hope this video has been able to help you, okay, to understand the concept better, right?